Hi, this is Harry Forbes. I'm at the 2018 ARC World Industry Forum in Orlando. My guest is Ricky Watts from Wind River. Ricky, you're the Industrial Solutions Director for Wind River.
Yep.
Ricky, Wind River has tons of experience in different areas of industrial automation and industrial products. Real-time operating systems, embedded technology, now ruggedized server technology. Can you kind of tell me how you see the market changing? Because you've been in it very many years.
Yeah, good question, Harry, and thanks for the introduction. It is an interesting time. I think if you look at the industrial market, particularly around automation and controls, the cycles have changed in the industry over a very long period of time. It's a very well-established industry. We have been working in that. We've been providing, as you say, embedded OSs in that market. But we're at an inflection point now. Things are changing. Cloud technologies have been coming into the market in the IT domain, and these technologies are being looked at, and how can we bring that into controls domain, automation and controls domain. So that's really, I think we're about to enter that transition. OPATH is a good sign of that, setting direction about where they want that transition to go. So it's really, we're moving into this new evolution of bringing that capability into the industrial market, but focused around controls and automation. They have very specific needs, and that's where Wind River comes in.
Okay, but this is, as you say, a point of inflection when people kind of move the traditional automation systems into a more of a virtualized or some kind of more, should we say, software-defined kind of solution.
Yep.
That's a major challenge for people in the manufacturing business, and I would say there's a few skeptics about that. So how do you help them with that? What do you see as the challenges for that?
Yeah, I'll say healthy skepticism is actually quite good. For me, as I said, we've been in this business a long time. This is an operational area. It's an operational business. These things have been running for a long time. They're incredibly important pieces of technology, and they've got to work. So bringing in a new technology like cloud obviously has some concerns. How are you going to do that? How are you going to manage those systems? And as I say, this is not pure IT cloud. This is about OT cloud, in terms of the definition. And what we're bringing in is effectively we're bringing that discipline into this new virtualization capability with a product called Titanium Control. And Titanium Control very much focused around operational market, latency, performance, availability. I always say, in my mind, if you're going to bring in a new technology, it has to be equal or better than the technology before. So that skepticism, the people that we're working with want to hear that. We want to make sure that the product we're defining for this market and getting through this challenge brings the new technology in, but is very focused around making sure that we appreciate all of that knowledge and bring that through as well. It's a combination of what's in the past and what's in the future, and bringing that back into the right combination to actually go forward.
Okay, that's a great point. And when you said equal, people can buy into it. It's got to be at least as good. Yeah. But what do you see as the things that are going to make it better, that'll make people say, oh, I'm not going to stick with what I have, I'm going to go to this new solution?
Well, many angles to that question. Let's start with it from there's a lot of information that's locked up in these plants and factories, and everybody's been looking at, this idea of doing predictive maintenance and analytics. That's just the start of this journey. Once you get access to the systems and the information that's there, predictive maintenance is just one part. There's going to be other ways that we look at it. Process improvements, the way that we can bring in robotics and other areas into the industrial manufacturing, morph these things together. So that's one area I see. Cost is another one as well. Cost is always a consideration. We're looking at, when we go forward, how can we improve the cost profile? So cost profile is not just about the hardware, it's about deployment. These technologies, when they're virtualized, I can speed up deployments. We've seen things, natural disasters occurring in, all over the world, where plants go off the air and things start to go down. If you bring in these technologies, we can return those services, get those things back up and running much quickly. So operational improvements, operational plant cost reductions, new services coming in with access to the data, And I'll add one thing. It's very important that we talk about plant, we talk about operation and controls. This is all done really where the plants are. So it's making sure we bring that technology into the plant and allow it to do those things. So I see many avenues and many opportunities. And again, I'll lead it back to OPATH. I think that's part of their thought process and where they're going. How do I bring these things together?
Okay, I'm very enthusiastic about their prospects too, and especially when you mention deployment. I think improved deployment and development paths are going to be a huge piece for this. There's one term that I'm really not familiar with, and since I'm surprised not to be, I heard from Wind River, which was called fluid computing. And I have no idea what that means. Can you help me a little bit?
Yeah, great question. It's I would say it's an evolution of where we've been going. We talk about cloud computing, we talk about edge computing, we talk about being at the edge, at the physical edge. We talk about all sorts of compute. And then we have systems that need to run within that compute. You know, operation and control systems, learning systems. Putting a definition and a constraint around that thing, around the way that those systems are, is really a constraint. So we look at it from a point, can we put all of the compute capability into a system so that functions and applications that need to run are fluid. They can move and run where they're needed. So if I have a tightly time-controlled loop that's got to run right at the edge, let's deploy it on compute at the edge. If I've got something which is requiring intensive analytics, maybe you want to put that up in the cloud, maybe you want to put it at a layer above that where you've got some more compute power. So it's really putting a system of compute in where the systems can run within that compute environment where they need to run based upon what they need to do. So we call that fluid. Okay. It's really just an evolution, but I'll just add one piece. You have to go back and adhere to the principles of what you're doing, which is, this is an operational, it's not an IT compute pool. It's all about making sure that the compute that you've got is applicable to the systems that you're going to deploy. So, you know, where you want high performance, where you want potentially safety systems, all of these things are strict requirements, and you've got to make sure your compute is capable of those things. It's not just, hey, we've got a massive, great big cloud and you can go and do this. It's very, very much designed around the needs of the industrial market.
Well, that sounds like something I'm familiar with in terms of that. So thank you very much for helping me understand what that means.
My pleasure, my pleasure.
Thanks for coming to the forum too. It's great to have you here.
No, I love coming here. It's a fantastic opportunity to learn about where the industry is going, and hopefully we can be part of that journey, and I'm really looking forward to it.
Thanks for helping us do that.
Thank you.
My guest has been Ricky Watts from Wind River. This is Harry Forbes from the ARC World Industry Forum in Orlando.